Good morning, members. Today we are going to see how do we integrate using by parts technique. Now, integration by parts is when you have an integral having a product of two different functions. They can also be the same. Now, all we need here is a hint, which is called the acronym. L stands for logarithmic functions. Some examples are there. Inverse functions, algebraic functions, trigonometric functions, the sine, the cos, the sec, and etc. Then exponential functions where we have this and this. That's what the stands for. Now here, we are going to also need this technique that when I integrate a sine, I get a negative cos. When I integrate a cos, I get a positive sign. And when I integrate this type of exponent, I get that. So here, we are going to use what we call the basic technique. Now, you can also use the formula, but today I'm not going to handle that. Now, this one, see, in the basic technique, you need to realize now, in my integral here, I have this as an algebraic function because it's a quadratic. And I have this as my exponential function. Now, in the Legat acronym, you see that now what the basic thing says, we are going to differentiate and also do what? Integrate. But the question is, what do we differentiate? What do we integrate? Now, what comes first in the Legat acronym is what we differentiate. It's that A comes first before the E. So it means that we are going to differentiate A. So what is A? A is the quadratic function. Here we have x squared. And then E, we are going to integrate this E. Now, we start by putting a positive. They are going to be alternative. When I differentiate this, I get 2x. The minus, second to minus. When I integrate this, when I integrate the x, I have ex. When I differentiate this, I get 2. When I integrate this, I have still ex because it's the same function. Minus, when I differentiate 2, I get 0. When I integrate this, I have ex. Now, my integral of x squared exponent x dx is going to be, this is now how we delete it. We take this like this and then like that. We take now this times this times that. This times this times that. And then you see this one is squaring, there is nothing, so I just said this times that. Now from there you see this times this, I have x squared exponent x. This times this minus 2x exponent x. Then this times this, I have plus 2 exponent x. Then this times this, I will have a 0. Then I put a constant of integration. Now in example 2, you see I have an algebraic function and I have a trig function. Now in my Legat acronym, you see that algebraic comes first, followed by trig. So this one is not about differentiate and I will integrate this. So now I put that, I'm going to differentiate. And this side I will integrate. Now, I start by putting a positive, or is a positive is the first sign we put here. Then what I'm going to do, because A comes first, my this time is x, I put it there. Then what comes next is the trig. Now my trig function is the sine. So I put here my sine x. Minus, when I differentiate this I get 1. When I differentiate this I get, now, when I integrate sine x, when I integrate sine x, I get a negative cos x. Now a positive, they keep on alternating. When I differentiate the 1, I get a 0. When I integrate a cos, now look at this, be careful. When you integrate a cos, you get a positive sign, but you have a minus, which when you multiply there, still will get a minus sine x. Now my integral here, which is x sine x dx, is going to be, now we are going to go the other one. So I go like this, there, then I come there, then I come like this, then I go like that. Now if I can come like this there, so I just tangent it by saying that like that. So now this times this, I have negative x cos x. This times this, a time negative times a negative, I'll get a positive, then sine x. Then this times this is a 0, then I put a constant of integration. Now, in this example 3 here, you see that we have an integral of x, natural log of x dx. Now we see that this one is a and this one is a logarithmic function. Now, in my acronym, you see that L comes first. So now, I'm going to differentiate, then I will integrate. Now, I start with a positive, but now, what I'm going to differentiate is what comes first. You see that L comes first. So I put here natural log of x. Then I'll integrate the algebraic this time round. So that's why I'm putting it here. I hope you now will differentiate this and you know how to interpret this. You can proceed. You try it out. I wish you the best.